Now the third one is the dollar weighted return. So dollar weighted return is focus on the cash flow. So we focus on the cash flow, not the return itself. So let's look at this scenario. So this scenario showed that, well, first year, so that's the third one, dollar. Now cash flow 0, so the initial cash flow is negative $1 million. That's the investment. So you invest $1 million, and then your initial asset is $1 million at the start of the first quarter. You make 10% returns, so asset will be $1.1 million, right? And then actually, so they invest another $0.1 million to increase the asset 1.2 million for here. Okay, so CF1 is negative $0.1 million, and then second year, so now we have 1.2 million, right? And 25% holding period return makes $1.5 million. And then you also have another investment, $0.5 million, make $2 million your seed money. Now third quarter, you have $2 million, but you lose 20%. So asset value drops to $1.6 million. Now you took out $0.8 million. Oh no, actually took out the positive cash flow right to you. Then you have $0.9 million left. Last quarter, now you have 20% return from the $0.8 million. So you have $0.96. Now you have $0.96 take out at the fourth quarter. So that's the cash flow. Find the IRR for this cash flow. So let's use the Excel. So let's go to Excel here. So let's make new file actually to find the return for. Okay. So this is the time. So say quarter. And then next one is cash flow. So from 0 to fourth quarter, right? Initially you invest 1 million and then 0.1 million investment, 0.5 million investment, and then you take out 0.8 and finally your 0.96. And let's find the IRR. So the dollar weighted return will be IRR for these four cash flow. And it's going to be about 3%. Let's increase the number of decimals. Yeah, 3.38%. That's the IRR, and that's the dollar weighted return. So the dollar weighted return will be 3.38%. Okay, that's how to find dollar weighted return. So arithmetic return is kind of simple average. Geometric return is now the scenario is we use compounding interest. And then the dollar weighted return, you generate the cash flow from the scenario and find the IRR. So in exam, you may have the question that requires you to solve these type of the return. Obviously, I'm going to give you this detailed scenario that you can solve for the IRR of the cash flows in to compute the dollar weighted returns. Okay. Now there are two different type of rate of returns again. Here, APR and EAR. So APR is simply the quoted rate. It's called annual percentage return rate. So quoted rate, which is the rate that quoted legally, and it's the per period rate, so like quarterly rate times period per year times 4, and ignores compounding. So if you have 10% APR, then your quarterly return is simply 2.5%. Okay. Now, if your compounding frequency is 4 times per year, it means that you actually make more than this 10% because principal recalculate like every quarter, right? So to find really effective rate, then we have to convert it to the EAR. It's the actual rate of investment growth. It does not ignore the compounding. So let's look at the example here, the formula. So EAR equals to 1 plus APR divided by N, which is the number of compound per period. So if it is quarterly, then it's 4. If it is monthly, then it is 12. Part to the nth minus 1. That's the EAR formula. And you can rewrite, like rearrange for APR equals to EAR plus 1. Part to the 1 over n minus 1 times n. That's the formula for APR. Now, for continuous compounding, there's called a continuous compounding because time is discrete variable. I mean continuous variable, I'm sorry, not discrete variable. So theoretically, the most realistic compounding frequency is the continuous. The problem is we cannot use this type of formula for continuous compounding because we don't know n. So we use the exponential function to find the continuous compounding. So for here, like continuous compounding, the EAR equals to exponential function to the APR minus 1, and then APR equals to natural log of 1 plus EAR. So that's for continuous compounding. Nominal rate and real rate. We know that inflation matters, right? So inflation changes the purchasing power. So even though you make like 10% nominal rate, like the quoted rate, your purchasing power may not increase by 10% because you may have inflationary economy. So we have to know how to compute the real rate, which is the rate for changing in purchasing power itself. So 1 plus real rate equals to 1 plus nominal rate divided by 1 plus inflation. That's for whole Fisher's equation. Okay, so example, what is the real rate on investment that earn nominal 10% return during the period 5% inflation? Then we just plug number here. So 1 plus real rate equals to 1 plus nominal 10% divided by 1 plus 5% inflation. Then we have 1.048. So R equals to this 1.048 minus 1, which leads to 4.8%. That's the real rate. So your purchasing power change in 4.8%. Now you can also use this Fisher's equation approximation. This is approximation. Approximation. It's very close to the nominal rate is close to real rate plus expected inflations. And in equilibrium, your nominal rate should be the sum of the real rate plus inflation. This is interest rate and inflation, real interest rate. And if you look at the before World War II, there's a lot of volatilities here, right? Because of the Great Depression era, and also that's the time that we have kinds of the turmoil like World War II. And then after World War II, there's a certain trend that the nominal rate have increased roughly in tandem with the inflation, right? So it's very close, like they go together. See? So that's a lesson for the interest rate.